Good day, everyone. Welcome back to Math with Trockers. So today we go through a specimen question to get a feel for the new syllabus and exam style. All right, so we have a question on trigonometric functions, differentiation, and coordinate geometry. All right, so the question reads 11a, item 1, prove that 1 minus 2 cos squared theta over sine theta cos theta equal to tan theta minus cot theta. Item 2, hence solve the equation 1 minus 2 cos squared theta over sine theta cos theta equal to 2, giving all values of theta between 0 degrees and 360 degrees. B, a circle is defined parametrically by the equations x equal to 3 plus 2 cos theta, y equal to 4 plus 2 sine theta, where theta is a real parameter. Item 1, show that the derivative is equal to negative cot theta. Item 2, show that the Cartesian equation of the curve is given by x minus 3 squared plus y minus 4 squared equal to 4. Item 3, describe fully the curve given in item 2. Lastly, item 4, given that the line y equal to 2x meets the curve in 2 at A and B, find the coordinates of A and B. Okay, so let's get the ball rolling, guys. All right, so we are going to start with the identity. So this is number 11. So on number 11a, item 1, so the identity, we need to prove that 1 minus 2 cos squared theta over sine theta cos theta is equal to tan theta minus cot theta. All right, so let me start with the right hand side and see where we go. All right, the right hand side here, we have tan theta minus cot theta. This can be rewritten as sine theta over cos theta minus cos theta over sine theta, right? And here we can express everything under the same denominator, right? So this into that, it's sine. So we have sine squared theta minus this into that, it's cos squared theta, right? But since this one is expressed in terms of cos, and we know from this identity that cos squared theta plus sine squared theta equal to 1. So sine squared theta is equal to 1 minus cos squared theta. So now we have 1 minus cos squared theta, right? 1 minus cos squared theta minus cos squared theta over cos theta sine theta, which is equal to 1 minus 2 cos squared theta over cos theta sine theta, right? So we are done. Sorry, supposed to be as required, right? Okay, so that's all about the first part. So item 2, it's hence. So in math, hence means use the above result. So we want to solve 1 minus 2 cos squared theta over sine theta cos theta equal to 2, right? So we are solving for all values between 0 and 360 degrees inclusive. All right. So now, remember it's hence. So this implies that tan theta minus cot theta equal to 2, right? So it's just tan theta minus 1 over tan theta equal to 2. So if you multiply both sides by that, we get tan squared theta minus 1 equal to 2 tan theta, right? And here we have tan squared theta minus 2 tan theta minus 1 equal to 0. So now we can use the quadratic formula. So tan theta equal to minus b plus or minus square root of b squared minus 4ac all over 2a. So a is 1, b is negative 2, c is negative 1. Okay, so tan theta equal to negative, so that's 2 plus or minus over 2 square root of b squared. That's 4 minus 4 times 1 times negative 1, right? So tan theta equal to 2 plus or minus over 2. So it's going to be 4 plus 4, that's 8. Right, so we have two solutions. Tan theta equal to 2 plus root of 8 over 2, or tan theta equal to 2 minus root of 8 over 2, right? So if we solve here, theta is equal to arc tan of 2 plus root of 8 over 2, or theta equal to arc tan of 2 minus root of 8 over 2. So here, make sure your calculator is in degrees, right? Let's make sure our calculator is in what? Is in degrees. Okay, so now I'll change to degrees. All right, so arc tan of 2 plus square root of 8 over 2. So here I'm getting 67.5. But there's one thing that we need to know, right? Remember this. The cast diagram, all students take calculus. So here it's theta, here it's 180 minus theta, 180 plus theta, then 360 minus theta. But since it's tan, so we are going to consider this quadrant and that quadrant. So since we have our principal angle is 67.5, another one, it's 180 plus 67.5. So it's going to be 67.5, 180 plus 67.5. I'm getting 247.5. So I have 247.5. Then when we come here, we do the same. So it's now arc tan of 2 minus square root of 8 divided by 2. So I'm getting negative 22.5. So I have negative 22.5. So I have negative 22.5. Then another one is 180 plus this. So when I add 180, so it's 180 plus negative 22.5. Then another one, since we want all angles within the range from 0 to 360, if we add 360 here, it's now 360 plus negative 22.5. So this one, we drop it because it's out of range. So that one plus 180, right? So I am getting 157.5. Then 360 minus 22.5, I'm getting 337.5 degrees. But remember, guys, for ZIMSEC, we are supposed to, if the degree of accuracy is not specified, we are supposed to approximate our answers to the nearest angle. So therefore, theta equal to 68 degrees, 158 degrees, 248 degrees, or 338 degrees. So these are the 4 answers for number 2. Okay, so now we are moving on to item B. So on item B, a curve is defined parametrically as, so this is B. So x equal to 3 plus 2 cos theta, then y equal to 4 plus 2 sine theta, right? So where theta is the real parameter. So item 1, we need to differentiate. So when differentiating, here we are going to do that parametrically. So we have to differentiate dx with respect to theta, dy with respect to theta. We apply the chain rule. So dx d theta. So remember, when we differentiate cos, we get negative sign, so that's 0, 0, so it's negative 2 sine theta. Then dy d theta, if we differentiate sine, we get cos, so it's going to be 2 cosine of theta. So now dy dx is equal to dy d theta divided by dx d theta. So dy d theta is 2 cos theta divided by negative 2 sine theta. So these 2 here will cancel out, and we remain with negative cot, right? That's negative cot theta. So we are done. We have shown the answer, the needed answer there. All right. So now item 2, we also need to show that the Cartesian equation is represented by x minus 3 squared plus y minus 4 squared equal to 4. All right. So what we need to do on item 2, right, we have to isolate the trig part there. So if we say x minus 3 over 2 here is equal to cosine of theta, then we do the same, y minus 4 over 2 equal to sine theta, right? Then after that, we apply this identity, cos squared theta plus sine squared theta equal to 1. So, right, so this implies, right, this implies that x minus 3 over 2 squared plus y minus 4 over 2 squared equal to 1, right? When we simplify, we get x minus 3 squared over 4 plus y minus 4 squared over 4 equal to 1. Then we multiply both sides by, or we multiply every term by 4. So therefore, x minus 3 squared plus y minus 4 squared equal to 4. And this is exactly what we are supposed to show. So we are done with this part. All right. As simple as that. Okay. So now item 3. So on item 3, we are supposed to describe completely this part here. So when describing that part, as you can see, the curve here represents the circle. So it's a circle with center, right? So this is a circle with center 3, 4, and radius 2. Okay, so that's the equation of the circle with center 3, 4, and radius 2, right? Okay, then lastly, I think on the last part, we need the graph part here. Okay, so the last part is saying, given that the line y equal to 2x. So we now have the line, so this is item 4. So we have the line y equal to 2x, right? Meets the curve in 2 at A and B. So the curve in 2 is x minus 3 squared plus y minus 4 squared equal to 4, right? So we need to sketch. So we need a diagram here in order for everything to make sense, right? That's x, that's y. So the center is 3, 4, right? So center is 3, all right? So I'm going to say 1, 2, 3, 4, okay? 1, 2, 3, 4, okay, 5, something like that. Okay, so center is 3, so 1, 2, 3, 4, it's, okay. On the x here, let me just be consistent. So on the x, let me just say 1, 2, 3, 4, 5, 6, 7. All right, so 3 and 4, 1, 2, 3, which is 1, 2, 3, 4 here, right? Then the radius is 2, right? So I'm going to extend this part. All right, so I'm going to extend that part. Okay. Okay, 1, 2. So that's why. So here, since this is 3, 4, 3, 4, radius is 2. So I'll move 1, 2 here, 1, 2 there. then 1, 2 here, then 1, 2 there. Right, so that's my circle. Right, so as you can see, this is 3, right? That's 4, that's 6, that's 2, right? That's 1, that's 4, 3, 4, that's 5. Okay, so we have our circle. Now let's sketch this. Y equal to 2x, right? When x is 1, y is equal to 2, right? When x is 2, y is equal to 4. So we now have that graph. Allow me to draw this in red, right? So I'm going to join that in that. Okay, it's something like that. So we are told that this circle here, the line y equal to 2x, and funny enough, if it's okay, I am seeing this 0.32, we'll just confirm. But we are told that the line y equal to 2x, so this is y equal to 2x, right, meets the curve at A and B. So this is point A and that point B. So we need to find the coordinates of A and B. So we have to solve simultaneously. So now, if I'm to solve, so y equal to 2x, that's the first one. Then the second one is x minus 3 squared plus y minus 4 squared equal to 4, right? So now I have x minus 3 squared plus, since y is 2x minus 4 squared equal to 4, right? Then, so this was 1 into, we substituted 1 into 2. So x squared minus 6x plus 9 plus 4x squared, 4 times 2, 8, minus 16x plus 16, right, minus 4 equal to 0. So this and that, it's 5x squared, negative 6 minus this, minus 22x, 9 plus 16 plus 4, 16 minus 4, that's 12. So this is 21, right? Yeah, plus 21 equal to 0 there, right? Then we need to find factors of what? Okay, if I multiply 21 times 5, I need factors of 105. So for factors of 105, okay, 105 divided by 21. Okay, cool. So it's plus 105, right? So factors, I think we have got negative 21 and negative 5. Let's see, 21 times 5, that's 105. So it's now 5x squared minus 5x minus 21x, right? Yes, plus 21. Wait, these two will never give me 22. All right, let's not do it this way. All right, let's just use the quadratic formula here. All right, let me see if I get okay, what about 15? 105 divided by 15. Okay, I have 15 by 7. So if I get 15 plus 7, that's 22. All right, so let's go ahead and use these ones. So it's now 5x squared minus 15x minus 7x plus 21 equal to 0. For this one, if you want to be safe, just use the quadratic formula. So 5x, x minus 3 minus 7, x minus 3, right? So 5x minus 7, x minus 3 equal to 0. And when we solve, x is equal to 7 over 5 or 3, right? But y equal to 2x, this is our first. So it means y equal to 2 times that, 2 times 7 over 5, or 2 times 3. So y equal to 14 over 5, or 6. So therefore, A is equal to 7 over 5, 7 over 5, 15 over 5, 14 over 5, I'm sorry, 14 over 5, right? Then B and B equal to 3, 6. Even if we go back to the diagram, I think now it's making sense, right? Here, as you can see, we hit that point, which was 3, 6, and here about 1 point something, 7 over 5, and 14 over 5, right? And guys, I think that's it for today's specimen question. Let's continue to do more practice. I'll catch you in the next video. Take care.